Hello everyone. In this video we are going to continue with our exploration of chapter 1 from the Stanley Barnett book. Chapter 1 is really offering a kind of breakdown of the core components of arguments. In the last presentations we dealt with really what the core ingredients, as it were, of arguments are. Recall that arguments are sort of the central unit that we're going to be exploring throughout the course, and they are made up of premises which supply us with the needed information in support of a conclusion, right? We have discussed the overarching structure of arguments in which premises are given in a manner that supports a given conclusion. In the last video, we discussed the difference between two large categories of argument. The first was called deduction, and in deductive arguments, the idea is that the conclusion, once established from the premises, is absolutely true, right? There's a kind of guarantee regarding the conclusion, in terms of which, if we accept the truth of the premises, it's impossible for that conclusion to be false. We're going to be exploring that idea a little bit further here. But we also contrasted deduction with inductive arguments. And inductive arguments are a little bit looser and appeal to the likelihood of a conclusion being true rather than the necessity of a conclusion being true. So just to move on a little bit here with the idea, one of the core properties of deductive arguments, we're going to be discussing the idea of validity, and we're going to be contrasting it with truth. So recall that in previous sections, I illustrated how in logic, truth value analysis is the investigation of whether or not the information in a given premise is actually accurate, right? So if I say the cat is sitting on the mat, and I ask you for a truth value analysis of that premise, we have a very simple task on our hands. We just look and see whether or not that cat is really sitting on the mat. So that's a kind of ordinary, intuitive way of going about the business of evaluating arguments. But we contrasted truth value analysis with what we called logical form. And logical form is ultimately what we're going to be much more interested in moving forward, because logical form allows us to look at the deep underlying structure of arguments in a manner that is quite separate from the truth value or the truth content of the premises. Okay, so we're going to be exploring a little bit that distinction in section 1F here, if you follow along with me. So the way that we typically describe this distinction in logic, or the term that is used to really specify logical form, is the concept of validity. Logical analysis tells us whether a deductive argument is valid or invalid. Now, you maybe have encountered this word valid before, or invalid, and you might have a sort of a common sense understanding of the meaning of that term. It might mean that this argument doesn't really work for you, or it's not very persuasive. And those things are true of the concept, but validity has a more precise technical definition in the context of logic. Validity in this context means that we have been given an argument where, if we take for granted the truth value of the premises, that is, we accept, for the sake of argument, that the premises given really are true, then it is impossible for that conclusion to be false, right? And so that's really the core meaning of a deductive argument. Deductive arguments are valid when, given the truth of certain premises, it is impossible for the conclusion to be anything other than the stated conclusion. So validity of deductive arguments is really going to be sort of the main thing guiding our interest as we explore various branches of logic, because, as we will see very shortly, that structure is going to allow us to look at some really interesting properties of arguments quite apart from their truth value, which is often a very messy and sort of complicated business. So what's an invalid deductive argument? Invalid deductive arguments are arguments where even if the premises are true, it is still possible for the conclusion to be false. Okay, so um, unlike a deductive argument that is valid, where we have to accept the truth of that conclusion with necessity, invalid arguments means something is too open-ended, or the conclusion is not necessarily following from true premises. It could be that the case that there is an alternative conclusion to the one that is given. All right, so this is again very sort of vague. It is easier to understand this terminology when we see some concrete examples of a valid argument and an invalid argument. But these are our technical definitions. Valid deductive arguments are ones where true premises make it impossible for a conclusion to be false, and invalid deductive arguments are arguments where even if the premises are true, it could still be the case that the conclusion is false. All right, so here is our full-blown technical definition from our textbook of validity. A valid deductive argument, and this is occurring on page 29, an argument in which, assuming the premises are true, it is impossible for the conclusion to be false. In other words, the conclusion follows necessarily from the premises. I want you to start trying to really have a feel and an understanding for what it means to say that a conclusion follows with necessity from premises. What is the meaning of that necessity we're talking about? The necessity means that it has to be true. The value has to be true, given the truth of the premises in question. Necessary in the sense that it is impossible to imagine an alternative conclusion given the truth of the premises in question. Okay, now notice that for a lot of the analysis of deduction and a lot of the analysis of validity, we're almost going to not be thinking at all about the truth value of premises. We're often going to be, unless otherwise stated, taken for granted that the premises really are true. And the reason we're going to be doing that is because we're not that interested in doing like factual empirical explorations of the statements covered in the book. We're usually going to be dealing with very, very obviously true statements or very obviously false statements, so much so that you really don't have to think very much about the truth value of the premises. And so we're going to be much more interested in validity and deduction than in induction. And we're going to find that you can do a lot more things actually with the properties of validity and invalidity just based on the formal structure of arguments. So let's have a look at a classic syllogism. A syllogism, as we'll explore in greater detail in later videos, is really a three-part deductive argument. It contains two premises and a conclusion. And I want us to kind of think about whether or not this example is valid or not. The first premise is all people are mortal. The second premise is Socrates is a person. Socrates is a famous philosopher. You take Introduction to Philosophy with me, and you'll learn all about Socrates and his contributions to philosophy. But we don't really have to know much about Socrates here other than that he is a person, right? So we have premises here. Now I want you to just kind of jot down for yourself what conclusion you think naturally follows from these two premises if we take for granted that the premises are in fact true. The conclusion you should have a kind of intuition for now is that Socrates is mortal, right? This conclusion seems to kind of be following by the necessity of the logic of the arrangement of the first two premises, right? We've already decided that all things that are people are mortal. Socrates is a person, and so he can only be a mortal, right? We cannot imagine him being anything other than a mortal, given the truth of these premises. So this is a very clean, tight deductive argument that maybe doesn't give us all that much information actually about the guy Socrates and what he thought. But we can see that there's a kind of interesting structure of inference being developed here, right? The inference is the leap between the premises and the conclusion, and we can see that this conclusion is moving in a manner that really is issuing forth with a kind of rationale to it, right? It is giving us information that is sort of already buried within the premises, as it were. So if you accept the premises as true, the conclusion must be true. This is a classic example of a valid deductive argument, right? It is impossible for that conclusion to be false if we accept premise 1 is true and we accept that premise 2 is true as well. Okay, let's look a little bit further here. I'm going to get out of the way at another example. I discussed it in the last video the idea of logical form. And logical form is the way in which we try to carve out the deeper structure of an argument from the content, from the subject, right? You're going to encounter a lot of arguments in the course that refer to things in the world that are really seemingly unimportant and seemingly pedestrian. And the reason for that is because we're trying to get a handle on the structure of arguments, the form of the arguments, and we're trying to deal with ideas that won't ask us to think all that much about content and truth value, right? So logical form is separable from truth value when we just kind of take for granted certain premises as true, and then we can just think about the structure. So we have an argument here that's another three-parter. The first premise is all beagles are dogs. The second premise is all dogs are mammals. Therefore, all beagles are mammals. And notice we are using our horizontal line to indicate the partition of the premises from the conclusion. That last line, all beagles are mammals, is the conclusion. This is an example of a valid deductive argument. It is valid because it is impossible for that conclusion to be false if we grant that premise 1 and premise 2 are both true. Now you can kind of just follow this in terms of thinking about, well, okay, if we're granting that all beagles are dogs and all dogs are mammals, those things are both, if they're both true, well, yeah, I can't really imagine beagles being not mammals, right? Or that statement being anything other than true. But pretty quickly we can get into some terrain that requires us to think a little bit too much about whether or not these premises are true or not. And so the way in which we separate out truth content analysis from logical form is to kind of strip the argument of their content and just give a little kind of symbolic notation that represents each premise. So the way in which we do this is to formalize the argument. We're going to learn how to formalize in much greater detail in subsequent videos, but for now we're just going to use the letters B as a kind of a stand-in for beagles and the letter D as a stand-in for dogs, and then we're going to use the letter M as a kind of stand-in or a symbol for mammals. And now we can kind of clear away some of the messiness of the content and just look at the underlying form of the argument. And that underlying form is this: all B are D for premise 1, all D are M for premise 2, therefore all B are M. So any substitutions in this exact form will also be valid. In other words, by substitution I mean we can swap out any content in the world for B, D, and M. And the arrangement of these terms will still generate a valid deductive argument. So you can see right away that in formal analysis, we're going to be clearing away content and subject matter very quickly in order to look at the underlying arrangement of the core terms. And you can see perhaps some patterns start to pick up with respect to the form of valid deductive arguments. You will notice that our first term in the first premise B is repeated as the first term in the conclusion as B. You will notice that the second term D is repeated as the first term in the second premise D. And you will notice that the second term M is repeated as the second term M in the conclusion. Over time, we're going to become very familiar with which patterns are always valid in deductive arguments, regardless of the content, right? And so this is going to be a very great and kind of efficient way of formalizing deductive arguments that take this structure, all right? Now, just to kind of flesh out a little bit further the difference between truth value analysis on the one hand and logical analysis on the other, it's important to note some of the characteristics or some of the properties that pertains to one rather than the other. With truth value analysis, we are really interested in the truth or falsity of statements. We really do have to think about whether or not the information supplied by a given premise is true, factually. More often than not in our book, we will be told whether or not a premise is true or false, or if it's false, it'll be so wildly obvious that we don't have to think for very long. It'll be a dead giveaway that the premise is false. And that's because we're not really going to be in this class, thinking about questions of fact and questions of concrete empirical evidence as much as we're thinking about the abstract structure of arguments. Unlike truth value analysis, logical analysis is concerned really with the connections between premises and conclusions, right? What is that pattern between the terms of the premises and the conclusion? So it's much more a question of structure rather than content. Truth value analysis has a binary system, right? The categories are either true or false. I've mentioned this in past videos. Logic loves things to be black and white. I like to think of the true-false value as a light switch, where things can be true and then they can be just as easily negated and made false. We'll talk more about that as we get into truth tables. But there's no kind of in-between true or false or gray area here in logic. We really are boiling things down to true and false categories. And that can be a very simplistic way of treating truth, and indeed it is a simplistic way. But it gives us quite a bit of leverage in the business of going about the evaluation of given arguments. Categories in logical analysis are not so much true and false as they are valid or invalid, right? We looked at a couple of examples of arguments. All men are mortal, Socrates is a man, therefore Socrates is mortal. Indeed, you had to think about whether or not it was impossible for that conclusion to be true in order to test the validity, but really the question of that argument pertains to its structure, whether or not it is valid or invalid, and not so much whether or not those premises are true factually. Truth value analysis might be easy or hard to ascertain depending on what those premises are about. And the reason for that is because it usually requires some past knowledge of the subject matter, right? If you didn't know who Socrates was, you might really not know anything about the truth value of those premises, and that's quite okay. And indeed, we'll get so many examples of arguments throughout the class that almost inevitably you'll encounter some subject matter that you're not familiar with, but that's typically okay because overwhelmingly we're going to be doing logical analysis, not truth value analysis. Determining validity or invalidity does not depend at all on determining the truth of the premises. Normally, when we are inquiring into the validity or invalidity of arguments, we will take for granted the truth of certain premises unless otherwise stated. Okay, so you need not concern yourself very often with knowing the information in the premises and knowing that a certain premise is true or not. Ordinarily, we are going to be taking for granted the truth of a premise unless it is stated that it really is false. Okay, so this is just a kind of schematic breakdown of some of the main differential properties of truth value analysis from logical analysis. Okay, so validity has nothing to do with the truth values of the conclusion or the premises taken separately. In other words, to understand the validity of an argument is not about just making sure that each sentence is true independently of each other sentence. Validity is really interested in the relations between the premises, and the conclusion. Is that conclusion following with necessity from the premise, right? That's really our definition of validity. So the sentences by themselves don't really mean anything for our purposes. It's really the overall totality, the overarching structure that is going to yield validity for us. Okay, there can be valid arguments with false premises. This is a very counterintuitive property of deductive arguments for new students to logic. There can be completely false premises that still are part of a valid argument. And the reason for that is that that conclusion can still be true by necessity, even with false premises. Okay, so we're going to have to see some examples of where this is the case, but just note that it is not enough to determine that an argument is invalid simply by discovering a false premise. That argument could still be valid with false premises. Validity speaks to the quality of the inference we can draw between premises and the conclusion, right? What is the flow of the argument? Remember, in the first video, we discussed the inferential leap that occurs between premises and the conclusion, and that is indicated by the horizontal line. Arguments are about the reasoning process, right? They're about the underlying structure and flow of the ultimate point that is being offered. They're not about the individual points or the premises independently of one another. Validity is about this inferential flow, this chain of reasoning that gets us from premises to conclusions. So the question you should always be asking with deductive arguments is whether or not the conclusion necessarily follows from premises. Can you imagine an alternative conclusion to the same premises? If you can, it means you don't have necessity. And if you don't have necessity, you don't have a valid argument. You have an argument that is too inferentially open to count as a valid argument. If we assume the premises are true, but it is possible to imagine the conclusion being false, the argument is invalid. Arguments are invalid in deduction when you can have an alternative conclusion, when a conclusion could be false with true premises. Now, it might be tricky to just glance at an argument and come to the determination that the conclusion could be false. And so we're going to have to develop a few techniques, a few tools for being able to really see whether or not a deductive argument passes through that criteria, passes through that filter of inferential necessity. And the key to that will be called the counterexample method, which we will explore. All right, so let's look at an example here. Forgive me for referring to myself, but this is kind of an easy one. If I have an argument like this, premise 1, if someone is a philosophy professor, they went to college. Premise 2 states Charles Prusik went to college. The conclusion, right, as indicated by the horizontal line, states, therefore, Charles Prusik is a philosophy professor. Now, I just want you to write down for yourself whether or not you think this counts as a deductive valid argument or a deductive invalid argument. Is this valid or invalid? And try to think about why. This argument is actually invalid. And this might be a little tricky because we seem to have sentences taken by themselves that are true, factually, right? Their truth value analysis is all good. However, there's something about the arrangement, the reasoning process, that doesn't quite work. This argument is invalid, even though the premises are true, and the conclusion is also true. This is because the truth of the conclusion is not logically related to the truth of the premises. In other words, the conclusion is not following with necessity from the premises. Something is being taken for granted or assumed in the conclusion here, such that an alternative perhaps could be supplied that is also true. So if I replace Charles Prusik with someone else, and you'd have a case of true premises and an untrue conclusion, right? If I were to replace the name Charles Prusik with the name Donald Trump, we would have an obviously false conclusion, right? With true premises. Okay, so substitution can be a very clean and useful way of determining whether or not that conclusion is following with necessity from premises. So we're going to call this the counterexample method. One way to prove invalidity is the counterexample method, providing alternative statements in conclusions with the same content in premises. And this will become easier to do as we formalize the arguments in question. So let's have a look at this. The counterexample method deals with the idea of putting to the test the necessity of conclusions in deductive arguments. Because deductive arguments are either valid or invalid, we can determine validity by providing counterexamples for conclusions to test the argument. The counterexample or substitution method, as I'll sometimes call it, is a way of formalizing arguments, right, to revealing their underlying structure to see if an alternative conclusion can be provided with those premises. If an alternative conclusion can be found, we know the argument is invalid, right? The conclusion of a valid deductive argument is meant to exclude the possibilities of true conclusions, right? It's meant to be impossible for that conclusion to be false and to be anything other than what it is, given the truth of those premises. I know this is all very kind of vague language, the counterexample method, but again, the sort of proof of the pudding is in the eating. It is all about doing some actual examples here. That's really the trick to developing this tool. So let's have a look at some examples. If I have a statement like this, all towers less than 200 years old are skyscrapers. And then I have premise 2, a sentence like this, all buildings made of steel are skyscrapers. And now we have this horizontal line, so a conclusion is coming. And I have a conclusion like this. Therefore, all buildings made of steel are towers less than 200 years old. Okay. This sounds like a solid, valid deductive argument, but we have to submit it to the test of the method to see whether or not that conclusion really is true by necessity. So let's kind of formalize the argument and bear down the content into its underlying structure in order to provide the counterexample. So let's use the letter T to symbolize towers less than 200 years old. Let's use the letter S to represent skyscrapers. And let's use the letter B to represent buildings made of steel. Now I just kind of ask you on your own to rewrite this argument just using these formal symbolic letters as stand-ins for each premise and conclusion. T represents towers less than 200 years old, S represents skyscrapers, and B represents buildings made of steel. The first premise, once formalized, should look like this. All T are S, right? We have towers less than 200 years old are skyscrapers. Line 2 should read all B are S. All buildings made of steel are skyscrapers. And then as our conclusion, all B are T. All buildings made of steel are towers less than 200 years old. Okay, so we have kind of stripped away a lot of this content, which might be a little clunky, right? The content of 200-year-old skyscrapers and buildings might sometimes send your head sort of spinning, so it's very useful to clear away all that content and just get the structure with this formalization. Now, what we can do is rewrite the argument and see if we can supply an alternative set of contents in order to determine whether or not this really is a valid argument. Remember our premises, all T are S, all B are S, therefore all B are T. Okay, so this is our structure. Now let's just create a whole new set of terms that we're going to use as the new content as a counterexample. Let the following substitutions create the counterexample. Let T equal cats, let S equal mammals, and let B equal dogs. So please rewrite the full argument with this new content. T equals cats, S equals mammals, and B equals dogs. Okay, our first premise now, having substituted out our form with new content, is this. All cats are mammals. All dogs are mammals, premise 2. Therefore, all dogs are cats. So this argument actually has the identical structure of our initial argument about skyscrapers and buildings. I want you to understand that. It has the identical formal structure. It just has totally new content. But now we can see that perhaps the structure of our argument has some deep problems with it, right? All cats are mammals. Is that true or false? Okay, that's true. All dogs are mammals. That's true. All dogs are cats. That's very obviously false. So we have a false conclusion, which means we have an invalid argument. Both premises are true and the conclusion is false. Therefore, the counterexample shows that the argument, the structure of the argument in general, no matter what the content, is invalid. For every instance of this formal structure, the argument is invalid. So our initial argument about skyscrapers and buildings, that argument is invalid too. All right. So this is a very nifty method that allows us to submit arguments to a kind of litmus test, as it were, in terms of their structural integrity. And it allows us to do that by cutting away the content, putting in new content, and seeing if we can generate a conclusion that is false on the basis of true premises. So this is a case where the counterexample method, or the substitution method, shows that our initiating argument is invalid. We're going to be doing a lot of work with counterexamples and formalization. If you're a little bit confused about it at the moment, that is okay, that is understandable. We're going to be developing this skill over time. But I want to move on just before ending to a new property of arguments, just to kind of keep the ball rolling, and that category is soundness. We've talked about validity and invalidity, but soundness is a different property. Soundness refers to whether or not a deductive argument really is true or false. It has to do with truth value rather than structure. So a sound argument is an argument where the argument is valid and the premises are in fact actually true, right? Remember, as I said before, you can have a valid deductive argument with true premises, but a valid sound deductive argument succeeds even further by having a structure that works and premises that are in fact true. So soundness pertains to deduction and validity pertains to deduction. Unsound arguments are ones where the argument is invalid and at least one premise is false. An unsound argument is invalid and at least one premise is false. So you can have a deductive argument that is valid where premises are untrue but still valid. You can have a valid argument that is also sound where premises are true. But you cannot have an unsound argument that is also valid. An unsound argument means it is also going to be an invalid argument. Soundness thus combines logical analysis, or the analysis of the underlying structure, with truth value analysis. It's a way of bringing together the concepts of logical analysis and truth value analysis. Okay, so where are we so far? Before moving on, I want you to make sure you understand the basic ingredients of an argument. Arguments are elements of reasoning that work with premises that are offered in support of a conclusion. Arguments have an inferential flow to them. In other words, the conclusion is meant to follow with necessity from premises. Arguments are either deductive or inductive. Deductive arguments are arguments where it is impossible for the conclusion to be false when the premises are true. Inductive arguments are experiential arguments that appeal to the probability of a true conclusion given true premises, but not the certainty of true conclusions. Formal analysis is separable from truth value analysis. Truth value analysis is an exploration of whether or not premises and conclusions are true or false factually. Formal analysis is an investigation of whether or not arguments are valid or invalid. That is, it's a look at the underlying structure of the relationship of premises to conclusions. We've had a little look at how to formalize the content of arguments by providing symbolic notation that represents parts of arguments, parts of premises and conclusions. And then we've had a look at the substitution or counterexample method, which allows us to test whether an argument is valid by substituting out the content or the premises of a given argument in exchange for identical structure with new content in order to see if we can generate an alternative false conclusion with true premises. We're going to be exploring further in future videos formalization and the properties of what makes for a valid and invalid argument. Before moving on, make sure you understand the basics of logic, of logical argumentation, the parts of an argument, premises, conclusions, the difference between deduction and induction, the difference between truth value and formal analysis, and have some sense of the meaning of the counterexample method.